although the timing for the technology was perfect, but the timing for the market, I don't know like if the timing for market is considered ripe even now, for that matter, for autonomous vehicles. So are there places like where the focus was on productionizing things? So you have something awesome, and how do you take it to the masses? How do you take it to scale? I fell in love with both of these different challenges, and definitely taking it to production. So we built this mapping platform, which is clearly a need for any company that's working on building an autonomous vehicle. Imitation learning and reinforcement learning both require a lot of data, and the way we can gather this data is from multiple methods. So it requires a lot more subtlety. Like when I pick this, like I also hear, or like when I'm not looking at it and place this mug here, I look at the sound of the third, like when I get it, when I put it, and then understand, okay, I actually reach the table and let it go. So I'm using audio, I'm using texture, I'm using friction. Like a lot of these things are very subtly and implicitly being understood by our brains. I want to take like what state of the art exists in like different dimensions or different areas and bring those together and build like a very stable, very scalable solution, which can be used like without having to run into terminals or without having to run into a lot of pain while running the software. Like using these tools should be pleasurable, so people can focus on real challenges rather than focusing on pain of running these things in the first place.
Welcome to Build and Beyond. Our guest today is Sri Kallakuri. Sri is an expert in the technology that enables driverless cars and autonomous checkouts. A graduate from one of the most prestigious engineering schools in the United States, Sri graduated from Carnegie Mellon with a master's in computer science and later went on to study artificial intelligence and multimodal understanding, which he decided to drop out of. He has worked across innovation labs in Dubai and Japan and is a two-time AI founder. Sri's first startup, Explorer AI, was about building a large-scale mapping platform for autonomous vehicles, enabling the creation, updating, and serving of maps for driverless cars. Explorer AI was later acquired by Standard Cognition, where Srikanth led the machine learning and computer vision teams, deploying autonomous checkout solutions and advanced retail analytics in real-world retail environments. Now he's taking on his next challenge with Dexter, solving the critical data bottlenecks that hinder the widespread adoption of robotics. Sri, welcome to the show.
Hi, Sam. Nice to be here.
Sri, you have a very interesting profile, and I want to unpack some of your story before we get into discussing the technologies that you've worked on. After your master's at CMU, you started your PhD in AI and multimodal understanding, but left midway. What brought that on? Was it the entrepreneur in you saying, screw this, I have the knowledge I need, now's the time to learn by building in the real world?
There are multiple reasons that led to that decision. Number one is there is a mismatch between my expectations from a PhD and what my advisor in the university were expecting out of a PhD. So that's number one reason. And number two is most of the work that I was doing in my PhD is not fundamental research. It's mostly application research. Mainly, it's a series of projects that I'm doing in order to actually bring machine learning and multimodal speech recognition into cars at that point. So I felt like the best way forward is to be more free in exploring like multiple directions of like how I can apply that in the real world rather than just being in a single dimensional way.
Interesting. So I would love for you to walk us through your journey with Explorer AI. I know that within months of your pre-seed round, you had your first pilot with an autonomous bus company in Minnesota, and then released an open-based map with a highly detailed map data for the city of Atlanta, where I actually went to school. I'm guessing you worked with some folks from Georgia Tech. Tell us more about how map data is the fuel for autonomous vehicles.
So autonomous vehicles, as you might already know, has like multiple parts in the stack which are very crucial, right? Like, so one is understanding of the world, like prior to actually starting to drive, like it needs to know like from where it is going and where it is and like where it wants to go. So it's just like our GPS maps, but just that it's more high definition in terms of like multiple modalities are added to the location, like the 3D map, 3D model of the city, and semantic information, like more granular than like what we have in our Google Maps, like specific information on like where the lane lines are, where the stop signs are, what the speed limit is at a particular point, and all that information embedded into a static blob, which actually gives you all the prior information required to drive.
Hmm.
That is very crucial. And like there are different schools of thought in autonomous vehicle development, like multiple companies working with like different ways to go about it. Like some companies make mapping the core component of this entire stack, where the map needs to be super accurate, super high definition in order for the robot to, or in order for the car to drive safely and more efficiently. And there are other companies, for example, Tesla, like which goes in a different direction where like map is just like an additional component. And most of the navigation and most of the planning is done with like the real-time sensing and like real-time understanding of the world.
Interesting. So, okay, let's dial back a little bit and let's go back to the basics and look at the foundational technology that makes autonomous driving possible. The brain, as we say, of a self-driving car. From my understanding, we can divide this brain into the following functional layers. There's 5 of them. There's sensing, there's perception, there's localization, there's planning, and then there's control. I know that at Explorer AI, you primarily worked on the middle three layers, correct? Which are perception, localization, and planning. Can we go step by step into each of those layers, what they are? And after that, we can go deeper into your work into those 3, perception, localization, and planning.
Yeah.
Yeah.
Perception is mainly looking through the cameras into the world.
Can we start with sensing?
Yeah.
Can we start with the first layer? Sensing. So sensing.
Sensing. Yeah. Sensing mainly comes down to what kind of different modalities through which you interact with the world. If the robot has just a camera, it's only interacting with the world with visual sensors. If the robot has like camera and a microphone, it's also interacting with like auditory and visual sensors with the real world.
Yeah.
Right. So specifically for autonomous driving, sensing comes down to cameras, LiDARs, which is light detection and ranging, the rotating sensors on autonomous cars that you see, which basically gives a depth map of the world. Depth information on like how far things are at each pixel or each voxel. We call it in 3D. And then there are radars, which basically gives like the velocity of objects moving around you. There are some Doppler radars, and like there are also some LiDARs, which include the Doppler mechanism to give like the depth map while giving the velocities of objects moving in the depth map, etc. And then there are obviously other sensors like encoders for the wheels to understand how fast the car is going. Or, there can be like any number of sensors that are regularly used in cars for assisted driving and other aspects. So the sensing component of autonomous vehicles is to bring all these sensors into a single coordinate frame. So if there are 2 cameras on 2 sides of the car, understanding the camera on the right is looking at the right side world of the car, and the camera on the left is looking at left side world of the car, and how far things are being detected in each of these cameras and transforming them back to the car origin. So all that piece of like getting these sensors up and running and making sure the sensors are synchronized with each other, making sure the sensors are synchronized with the car operating system, and also getting the coordinate frames of the entire world and these sensors is sensing. Perception is once you have this sensing, once you have information from these sensors, what you make out of it. So if, for example, if you take a camera, if you're looking at a person, detecting that it is a person and coming up with like exact location where that person is in the frame or with respect to the car, and understanding whether they're moving or walking or they're standing, or and predicting like how they will move in the near future. Like will they come in the way of the car's trajectory, or will they just stop there, or basically understanding that. And the same with like understanding how the vehicles are turning, understanding where we are. Even some part of perception is also about looking at the world around you and understanding where you are, which overlaps with localization. And again, one thing to make it very clear is like the borders between this different parts of the stack are pretty gray. Obviously, some part of perception like slowly merges into localization. Like it's not like hardly drawn lines.
Understand.
So that's perception, making sense of what you see from the sensors. And then there is localization, which is understanding precisely where you are. If you want like an approximation of where you are in the world, GPS is sufficient. Like it
GPS,
gives you
yes.
like 3 meters to 5 meters to 10 meters, depending on like how the coverage is in a particular region for the satellites. But basically, for autonomous driving, you need much more granularity than multiple meters of error, right? So you need to understand which lane you are in a street, or you need to understand like whether I'm in the middle of the lane or not, or how far I am from a stop line, stop or stoplight or stop signal. So things like that. Like so, you need much more granular understanding on precisely where the car is, and that's localization. And then there is planning, which is coming up with like a plan or a trajectory on like how the car needs to navigate in this world. So if there are three cars in front of you, understanding their velocity and and like basically coming up with a plan on like should I accelerate or decelerate, or should I change lanes? Should I turn here? So that planning includes two parts: local planning and global planning. Global planning is about like going from point A to point B in a GPS map, and local planning is seeing the real-time obstacles and real-time changes to the world and navigating accordingly. And
Okay.
what is the last thing you mentioned?
The last one's control.
Control. Yeah, control is basically making this plan turn into reality. So basically giving commands to the motors of the car so you actually move the car in the way that you expect it to move.
Okay, interesting. So before we kind of move ahead, I want to understand. I think there's a few key terms that we should define for our audiences. What is imitation learning and what is reinforcement learning? Because I believe that is key for people to understand how this technology works.
Yes. So imitation learning and reinforcement learning are relevant not only in autonomous vehicles, but in today's world, imitation learning and reinforcement learning are much more relevant for AI and specifically robots.
Okay.
Imitation learning is like looking at an expert perform a task and learning from it. So if you're talking about autonomous vehicles and imitation learning, basically you might have seen a lot of autonomous cars going around like with real people driving for quite some time. And that was to understand like how experts actually navigate in different scenarios and learning from it. If a person like sees a child far away playing with a ball, maybe if they slow down, that's information that's like not directly drawn from sensors. Like obviously, according to sensing, the person is far enough and the trajectory is unpredictable, so we don't know where the person would go and all. But the person might slow down. That's a very vague example, but the point is looking at how experts perform a particular task and learning from it is imitation learning. When it comes to robots, it's the same. Like, so if I have to pick this mug of coffee, like how exactly humans do is like a lot of there are a lot of complications in it. Like, so where exactly you hold this cup? Like, do you put your hand like this and hold, or do you hold it from the side? And understanding the grasp and all those things for any real world object is very hard to predict for each and everything. So looking at humans doing things and applying to robots is easy. And that's why imitation learning is getting more popularity in robotics now, not as much on autonomous driving. And reinforcement learning has proven to be successful not only in autonomous vehicles, robotics, but also specifically on the LLMs scenario as well. So reinforcement learning is doing things and getting penalized or getting rewards for certain things that you're doing and understanding what is the right thing to do. If you have a task to achieve, for example, if you take an autonomous car scenario, if you want to go from point A to point B, you might start driving, and if the distance between the car and the goal is increasing, then you will be penalized for it. Obviously, you're going in the opposite direction.
Okay.
So you correct it by going towards the goal, so you get rewarded for it. So again, I'm giving very vague examples here, but the idea is the same. Like even in ChatGPT, if you ask a question and you get a response, and if you ask the same question again, then it's getting penalized for that response.
Hmm.
If you move on to the next question or build on top of it, it gets rewarded.
Yes,
So
correct.
that's
Yes.
that's why basically these chat engines are improving a lot, like when people start using it more and more.
Correct, correct. So essentially, whether it's imitation learning or reinforcement learning, in both those scenarios, there's a ton of data being ingested, a ton of data being utilized. So, according to you, what is the current landscape of data collection and data labeling for machine learning? I know there are some companies like Scale AI, there's Cloud Factory that operate in this space. But I'd really appreciate if you could give us a rundown on this.
Yeah. Let's specifically talk about uh, humanoid robots or general purpose robots
Sure.
in this
Okay.
scenario, because like that's what is gathering more attention these days, and that's what I'm specifically focusing on these days.
Hmm, hmm, hmm.
Imitation learning and reinforcement learning both require a lot of data, and the way we can gather this data is from multiple methods, right? Like one is definitely you can have like a real robot perform a task and learn from it.
Hmm,
So for imitation learning, it's like human operation or teleoperation, or
hmm,
like making the robot perform the task with remote control and record the data and understand like how that is done and learn from it. On the reinforcement learning side, you can do it with simulated data or synthetic data generated, because like you can actually
hmm,
place a robot in a simulation environment and
hmm,
make it pick and place things and
hmm,
understand like how good the motion is. Or you can
hmm,
also do reinforcement learning data collection with real robots placed. And
hmm,
for example, if you want a robot to pick this mug, you can
hmm,
actually have a robot stay here and like give it a task of like pick this mug and like place it somewhere else.
hmm,
It will fail like hundreds of times. So it might like hold it the wrong way, it might spill the coffee in it, or it
hmm,
might hold it and lift it and then drop it,
hmm,
etc. So it'll learn
hmm,
by
hmm,
doing more and more and understand like what works and what doesn't work, and from there
hmm,
gets an understanding of the world. The problem with these methods are like they're very effective but like very costly. Currently, the
hmm,
data collection that is being used for robotics is super expensive, in the sense like most of these data collection methods require real robots
hmm,
to be performing these tasks, or
hmm,
people standing with the robots, or like people directly controlling the robots to do certain things.
hmm,
That's good for the current state of proof of concepts or creating demos for a lot of companies.
hmm,
But when you want truly general purpose robots, truly give the capabilities of a robot
hmm,
being able to just manipulate things like how humans would do
hmm,
without ever seeing a particular object.
hmm,
For that, you need like much more scalable data collection. Data
hmm,
from internet is one option for that.
hmm.
But at the same time, data from the internet is much more noisy, and it's not as simple as language. So the reason
Okay. Hmm,
data from internet is sufficient for language models to improve quite a lot was
hmm.
that language has some rules, like it has grammar, it has some rules that we all agree upon. But when it
Sure.
comes
Hmm,
to doing things, we have rules set by physics, like how the gravity works and how object-to-object interactions work, how different material properties of these objects impact, like how they're
hmm,
manipulated, they're interacted with. But there is no one way of doing things, or like the variety of the real world is a lot more, and with
hmm,
variety of how people
hmm,
are, like how people interact with things, manipulate things, is like
hmm,
insanely wide.
hmm.
And most of this data is not captured just with video information or language. So it requires a lot
Okay.
more subtlety. Like when I pick this, like I also hear, or like when I'm not looking at it and place this mug here, I look
Hmm.
at the sound of the third, like when I get it, when I put it, and then understand, okay, I actually reached the table and let it go. So I'm using
Fair.
audio, I'm using texture, I'm using friction. Like a lot of
Hmm,
these things are very subtly and implicitly being understood by our brains.
hmm,
And applying that to robotics requires like dedicated data collection.
hmm,
And as you said, there are many companies like Scale AI, which focus on more machine learning backed data collection, or like making data collection more efficient with machine learning models.
Hmm.
And there are companies like which have like a large human workforce like across the world.
Hmm.
And most of them are oriented towards the modalities of images,
Hmm.
videos, and language.
Hmm.
There are very, very few companies that are capable of collecting
Hmm.
robotics data.
Hmm.
To my knowledge, like no one has like really stable workflows and all.
Hmm.
And that's why like I'm focusing on building a platform which gives those kind of capabilities to collect this data
Hmm.
in the real world or
Hmm.
in simulated environments or with like the video data and
Hmm.
making it more production ready and more efficient.
Interesting. So I kind of want to understand a little bit more about how did you run into the problem that you were solving? You were essentially, you looked at the problem which was for driverless cars, there's a requirement for AI mapping that needs to take place. So how did you go into that? The reason why I want to go deep into this is because I want to understand what was your understanding of the problem before you started building. Because much of how a founder builds is a function of the way they think about the problem in their head. So what was the problem in your head? I kind of want to understand that, and how did you kind of stumble upon it?
I mean, obviously, I want to go a couple steps into history, like to answer that question. So
Mhm.
I started my career working specifically in research labs. So
Correct.
most of my
Yes.
work was on building things which were never built before, or doing demos or creating things to publish a paper or something like which was never seen by anyone.
Hmm.
That requires a way of thinking for innovating and building something from scratch and
Hmm.
just making something work. Later in my career, I worked at some companies like Emirates Airlines and other places like where the focus was on productionizing things. So you have something awesome, and how do you take it to the masses? How do you take it to scale? How do you actually make a lot of people use that? I fell in love with both of these different challenges. One is like building something new, and definitely taking it to production.
Hmm.
So, looking back and connecting the dots, most of my passion for the companies that I started comes from the fact that I know what is possible in research and I see what is possible in research, and I'm familiar and in some aspects, like I have the expertise in some areas of what to build in a research lab.
Sure.
And I'm passionate about like making it more widely available. So taking
Hmm.
research into production has been the North Star for me in my life.
Interesting. Interesting.
And in autonomous vehicles specifically, yeah, so I know what is possible in mapping. I know that like autonomous cars are coming.
Hmm.
And I realize like um, how not stable or how unstable or like how not ready for production the software for robotics is at that point. So I wanted
Hmm.
to take like a specific problem and work on making it like a solved problem by productionizing it, by taking like whatever is the state of the art at that time. And exactly
Hmm.
that's what I'm doing even now with robots, or
Hmm.
like the Dexter, which is like data collection solution for robots,
Hmm.
where I'm I want to take like what exists right now, the state of the art, and I want to take like what state of the art exists in like different dimensions or different areas
Hmm.
and bring those together and build like a very stable, very scalable solution
Hmm.
which can be used like without having to run into terminals or without having to run into a lot of pain while running the software. Like using these tools should be pleasurable so people can focus on real challenges rather than
Hmm.
focusing
Yes.
on
Hmm.
pain of running these things in the first place.
Yeah. So, what do you think are the biggest misconceptions or myths that you would like to address about the use of data in autonomous vehicles? Basically, what are the misconceptions in your industry? What do people consider easy or difficult that actually is not? Where in that industry value chain are most people's assumptions flawed?
So for autonomous vehicles, there are multiple aspects. Like so, One on the philosophical side, I can give an answer, and then we can talk about some technical
Mm-hmm.
aspects. Like on the philosophical side, or from the entrepreneurial side, it's like identifying something that people need or companies need, specifically in B2B kind of solutions,
Mm-hmm.
doesn't mean that the product is wanted by them. So
Okay.
it's very not obviously intuitive that like if someone, I mean, obviously we feel like if someone needs something, then there is market and business for that. But that's not true always. Like, so in most cases, what happens specifically in deep tech is companies will have needs, which is very obvious. But at the
Mm-hmm.
same time, they may not want to buy a product that solves that, or product or service that solves that need of theirs.
Mm-hmm.
And the reasons could be like a million. Like one, they it may not be a priority for them. Or second, like they might have like a some hacked up version in-house that just works and that they're happy with it. Or there can be any number of reasons. So
Mm-hmm.
that's one thing, which is sort of a misconception that if you have like a product or service that is needed by someone, then it will be sold is not very
Mm-hmm.
obvious when it comes to deep tech.
Mm-hmm.
And the same with Explorer AI. Like, so we built this mapping platform, which is clearly a need for any company that is working on building an autonomous vehicle.
Mm-hmm.
But what happened was it was not wanted by them like very explicitly. So everyone has the need, but like it's not on top of, like they have in-house teams which are small, but still sufficient enough for them to build what is required for their their work at that time. In 2017, obviously, not everyone is looking at running autonomous cars everywhere in the US. So we were building a platform where you can have the map very up to date and very fresh and very accurate for every
Mm-hmm.
corner in the country, for example.
Mm-hmm.
And that's a need, but like the timing was not perfect. Although the timing for the technology was perfect, but the
Mm-hmm.
timing for the market is not. And like I don't know like if the timing for market is considered um, um, like ripe even now for that matter for autonomous vehicles. So yeah, there's a lot of um, like subtlety in understanding the need for the customers and building for it and expecting
Mm-hmm.
um, them to buy it and pay for it.
So, Sri, I think you alluded to something really crucial. Uh, there's something to be said about getting the timing right when it comes to startups, and especially those that are deep tech. I remember a quote by Don Valentine of Sequoia. I remember I was watching his Stanford lecture where he talked about market readiness. I'll just read out that quote for us. The critical thing is getting the product developed in a way where the timing of the product's availability and the market demand are simultaneous. I think that's exactly the kind of problem you faced. That even though you were solving for a deep problem, you were solving for a problem that people did want solved, uh, but the market itself wasn't ready to absorb it. And as you said, like it still isn't to a large extent. It still isn't. So looking back, how do you reflect on that? What would you have done differently, and how have you incorporated those insights into what you're building right now?
Yeah, that's a great question, and also that's a great perspective that you shared from the court.
Hmm.
And like you rightly said, even autonomous vehicles are not ready, or like the market is still not seeming absolutely ready for autonomous vehicles. And like there are two things, right? Like there is product availability and there is market demand, but there is also the feasibility of the product availability, right? Like so, if autonomous cars are 100% or like 99% safe, and they are like as much as like a regular car would cost, the adoption would be like instant. But the problem there is like autonomous vehicles are much more expensive and they are still probabilistic in a lot of cases, like where you don't know how they will behave in instances like where there is no data that was seen in the models before, and things like that. So yes, number one, it's hard to time based on what the market demand would be and what the when the product availability happens.
Yeah,
But
it's almost like no one in the VC world can predict that either.
yeah, so and
No one can.
also
Yeah.
to your question on like how I would do things differently, specifically on the timing aspect, I don't think I would do it differently,
Hmm.
because the
Hmm.
time
Hmm.
to build tech for autonomous vehicles
Hmm.
was about like 8 to 10 years ago, or like start
Hmm.
working on it like 8 to 10 years ago and work till like maybe 6 years ago or 5 years ago,
Hmm.
or it's going to be again in a decade from now when
Hmm.
there's going to be like a real scale of these autonomous vehicles everywhere, and
Hmm.
you actually see the real problems of those happening.
Hmm.
So not doing it then and doing it now wouldn't make sense anyways.
Correct.
So
Yeah. Yeah.
the
Yeah. Hmm.
entire expectation of the world, from the VC side, from the people side
Hmm.
even,
Hmm.
was that like everyone hoped for autonomous cars to be everywhere,
Hmm.
so
Hmm.
ubiquitous, like by 2020 itself.
Yeah.
So everyone pushed for that, but it just didn't happen. That's sad.
Hmm.
And that's good thing. That's one good thing about deep tech or working on future technologies, is that even if you're wrong on timing, as long as you're not late, you're still contributing to the development, or like you're still
Hmm.
contributing to the
Hmm. Hmm.
forward growth of the technology, right?
Hmm.
So
That makes
whatever I
sense.
build, like
Yeah.
I still feel like it helped autonomous cars or some sort of computer vision or autonomous
Hmm.
vehicles to accelerate.
Yeah.
But it's just like the business did not succeed, is all.
Sure.
So I don't regret anything in terms of the timing decisions that was made on working on autonomous vehicles at that time. And the entire world was hoping for it. So the timing
Hmm.
was
Hmm.
not, or the market demand is not there, but like the market always wanted this.
Wanted it.
So
Correct.
everyone
Yes.
wanted
Hmm.
autonomous vehicles to be successful,
Hmm.
even the VCs or the people that are developing these
Hmm.
technologies, and also the actual public.
But
It's
the
just
factors,
like,
the
yeah,
factors that would need to be in place for the adoption to actually happen, that's what was missing.
yes, absolutely.
Okay.
So,
Okay.
but still, I feel like whatever we did contribute to
Hmm.
the autonomous vehicles, to accelerate certain aspects of it.
Hmm.
And I'm happy about it.
Hmm.
And coming to acquisition by standard cognition for a different use case, um, definitely like we kind of were early in foreseeing how the autonomous vehicle space is going to turn into like in the coming years in 2018.
Hmm. Yeah.
Specifically in terms of the consolidation that happened with autonomous
Hmm.
vehicles.
Yeah. Yeah.
Individual startups being crucial parts of this autonomous vehicle stack, and
Hmm.
everyone being independent and contributing didn't
Hmm.
seem plausible for us, and which turned out to be
Hmm.
true later on. By 2020, 2021,
Hmm.
all the
Hmm.
startups working on autonomous vehicles were
Hmm.
consolidated into like four or five major players.
Okay.
So
Okay.
each of these
Hmm. Hmm.
players have like a hardware company acquired, has a mapping company acquired, has a
Hmm.
um, like like a design company acquired, and everything.
Hmm. Hmm.
And so we realized that, and we didn't see the scope for running a startup like that develops just like part of this technology.
Hmm.
And to avoid anything that's like not a great outcome of starting a startup, we started engaging people who were approaching us. And there are a lot of big companies, like now some of those don't even exist,
Hmm.
like Uber ATG, and some teams within Meta. So we got like acquisition offers from multiple companies.
Hmm.
But the reason we
And
chose standard cognition.
what industries were these companies from? The ones that proposed to acquire you?
So Uber ATG was working on autonomous vehicles.
Hmm.
It's like the autonomous driving part of Uber.
Okay.
Uh,
Okay. Hmm.
and Meta's, the team that was interested in acquiring was like the Oculus team at that time.
The
So these
what
were
team?
like
The Oculus team?
Oculus, Oculus,
Oculus team.
yes, yeah,
Okay.
because like
Okay.
we were building 3D spatial maps, right?
Right. Correct. Okay. Hmm.
And standard cognition was interested for the same reason, to get like spatial understanding of the world.
Hmm. Hmm.
Um, It's like a different use case, but the application of technology is pretty similar to whatever application we were doing. Like, so basically, we were building
Correct.
maps for outdoor environments where cars can drive and cars can understand
Oh, okay.
where XYZ is with
And
respect
now you
to
just took that and took it
everything
to
else.
the indoor use case.
Indoor environment, absolutely.
Okay.
So
Okay.
how do
Okay.
you represent a convenience store? How do you
Yeah.
mark an exit, and how do you know when a person walks into an exit? Or how do you
Interesting.
if you have like a
Mm, mm.
particular SKU in a store, how do you
Sure.
represent the 3D coordinates of that in the store? So all that
Okay.
information. So
Okay.
that's one reason. And the second reason is Standard Cognition just raised Series A at the time, and it was small enough for us to not have any missing gap in learning the trajectory of a startup. So we were like 12 people when the time we got
Mm,
acquired, and
mm,
Standard Cognition was like
mm,
25 or 28 people at the time.
mm, mm,
So we didn't miss much in seeing the growth of a startup from scratch to
mm,
becoming like a unicorn, which
mm,
Standard Cognition was.
mm. So, what exactly was the value of what you had built at Explorer? I want to understand the value of the technology that you had created to standard cognition. The reason why I ask this is because I want to understand, like, when you think about defensibility, right? When you're building something like Dexter or Explorer AI, what is it? Is it the data? Is it the model? Is it the loop? Is it the team? Because a lot of VCs always talk about how the team is what makes a company. What do you think it is, or is it something else entirely?
Yeah, so that's a wonderful question, to be honest.
Hmm.
And I definitely will put team as the number one um, aspect that you can use for defensibility, because
Hmm.
when you're working on startups, you, you know what you're working on, but like there is a very good chance like things are going to change at any moment. So you may have to
Yes.
pivot to a different
Yes.
application or a different
Yeah.
area
Hmm.
altogether and everything.
Hmm.
So a team that is motivated and that is smart and that is well knit
Hmm.
is what like will make any company successful or failure. And the
Hmm.
second aspect is the building blocks you build for your company. So not
Hmm.
like the whole package solution, but like what are the subcomponents which can be utilized to build any other application if required, kind of situation.
Hmm.
Like we built calibration software at Explore AI, which is a building block for mapping. And we took that to
Hmm.
standard cognition, which was like directly usable. Or we had like multiple aspects of 3D spatial representation in for mapping in Explorer AI, and
Hmm.
which was directly applicable at standard. So having these building blocks which are usable and which
Hmm.
have like their clear protocols to be plugged and played at in different environments, I think that and the team, both of those will make it very defensible.
Interesting, interesting. So I kind of want to move on from Explorer AI to your second startup, which you're building right now, right? Well, before I go into what Dexter is, I would love to understand, like, can you break down what robotics is for people who don't know what robotics is? What is robotics, if you were to explain?
Yeah, what is robotics is a is a big question. Like you
Yeah,
can go very philosophical in answering that,
yeah, yeah,
but I'll try to stay short. Like
yeah.
basically, um, the robotics that we talk about is
Yes.
mainly the robots that have actuators and sensors plugged
Hmm.
together.
Hmm.
Obviously, as per the definition of robotics, which oh, for FAI, like so, there is no one definition for robot. So you can
Hmm.
call a ceiling fan a robot, like if you want, like practically, like it
Really?
fits the
Okay.
definition.
Okay.
Yeah. So
Okay. Yeah.
any machine that like they say in 3D, it's like any machine that makes life easy can be a robot.
Okay. Okay. Okay.
So
Yeah, that's what I was looking for. Okay. Okay.
yeah, but like the robots that when we say robots in general conversations, like what we refer to is something that like looks at the world, perceives the world, and acts accordingly. And autonomous cars
Interesting.
can be robots.
Okay.
Autonomous cars are robots, like not can be.
Yeah. Yeah.
Um,
Yeah. Yeah. Hmm.
yeah. So specifically, the kind of robots that I'm currently working on is humanoid form factor. So not the entire humanoid form factor, but like either robot arms or the form factor that actually helps you manipulate and interact with the real world. It can be
can you explain one more time what humanoid form factor means?
Yeah, humanoid form factor basically means a robot that looks like humans, a robot with bipedal navigation or mobility capabilities, like with two legs, two arms, and a head and a body and a torso.
Okay.
So that's humanoid form factor. That's what we imagine when someone says robot, like we imagine a robot with a head, two hands, torso, and a body, and like legs, right?
Yeah.
But there is also parts of that, so you can take a robot arm, which is built with inspiration from human arm. So basically, some joints that work together and some end effector or like a gripper or like so end effector like could be a suction cup or like a gripper or like anything. So yeah, so that's humanoid form factor, and also the parts can be taken out. Like so, there can be there can be a robot which looks like a human with head and two arms, but instead of having legs, that might be on a mobile platform with wheels. So these are all different combinations that are possible.
Okay. So essentially, for robotics, the core problem that you're working towards right now is addressing the data bottlenecks for the adoption of robotics. Can you tell us a little bit more about that problem, and also maybe what are some other core issues, problems, bottlenecks right now in robotics, both on the building side for the people who are building as well as on the customer side?
Currently, I'm focusing on building a solution for data collection and data labeling and data management for robots. And to give a little background, currently with all these advances in large language models and video language models and all the developments that you have seen for the last 4 or 5 years, those have fueled a lot of acceleration into understanding the world, right? Like how do you understand the world around you? And the next step for that is how do you interact with it? So how do you actually get things done by understanding this world? So if you have a world model on like, okay, this is a monitor, this is keyboard, this is a table and everything. And then now if you want to achieve something, now if you want to move an object from point A to point B, how do you do that is what the next horizon for the industry is currently. And in order to make that happen, definitely you need more granular data on how to do things and not only just understand things. Like large language models and whatever is available on the internet helps you understand things better. And what I'm trying to build is a solution which will help you gather data in how to manipulate things, how to get real world physical actions done with robots.
What kind of real world physical actions are we talking?
It can be anything. Like so, the most popular example you might have seen from a lot of companies working on robots is folding laundry. So if you have laundry, how do you make a robot fold it as a human would? Because like that's a very, very complicated task. Like that's such a seemingly easy task is very complicated
for humans,
for robots because
yeah,
even for humans
yes.
and
yeah.
Or the actions could be cleaning, like cleaning dishes or something like that. Or the actions can be very specific in industrial applications. Like if you have pick and place actions to be performed on an assembly line, that can be an action. So it's like a wide variety of areas like where this can be applied.
What about teaching them how to cook? That would make our lives easier in the US, right?
Yeah, absolutely. Yeah, definitely. Like so like there are some companies focusing on taking these recipes and exact kind of ways like how Michelin star cooks would do something and make the robot like do it for you. So yeah, like people are working on it so soon.
Okay, I think so. Within robots, there's two types of robots, right? There's industrial robots and there's general purpose robots. You already mentioned some of them already in the answer, but just so that people know the difference, can you tell us, what are industrial robots and what are general purpose robots? How are they different?
Yeah, Again, like a lot of things in robotics, there is no one definition for what an industrial robot and what general purpose robot is, but I'll give you my opinion
Okay.
or my understanding or
Hmm.
how I see things.
Hmm.
Industrial robots are mainly like robots which are for specific purpose, like in an environment that may not change too much. For example, if you have a robot arm on an assembly line, if you want to just like pick something from one line and place it on a different line, obviously like a robot can do it like so efficiently. It can do like a million times a day compared to a human doing like maybe 100,000 times a day or 10,000 times a day.
Hmm. Hmm.
So a robot like which is set up in a specific environment and not like in a very familiar environment and
Hmm.
not changing and or not too dynamic kind of environment. So
Hmm.
that's what I call an industrial robot to be. And
Okay. Hmm.
a general purpose robot is like a robot that can do anything that a human can
Hmm.
do, like
Interesting.
in
Okay.
terms of
Hmm.
manipulation and interaction with the world.
Okay.
So
Can
if you want to,
can you extrapolate a little bit on the manipulation and communication with the world part a little bit more?
yeah.
Can you expand
So
on that?
manipulation. So how we interact with the world is we see the world from our senses, right? Like we see,
Correct.
hear
Yeah.
a lot
Yeah.
of things. But the way we interact with the world is
Hmm.
with our arms and legs mainly,
Hmm. Hmm.
or like voice. Obviously, we
Yeah.
communicate with voice, but
Hmm.
most of the physical changes that we do in the world is using our
Hmm.
arms and legs, right?
Correct. Correct. Hmm.
And how do you uh, manipulate things in the world? It comes
Hmm.
down to manipulation aspects.
Hmm.
And there are a lot of additional aspects there. Like you can actually interact with the world and like understanding the texture of a table or understanding the smell in a room, for example. So these are all ways in which we interact with the world. Specifically
Okay.
for robots,
Hmm.
it comes down to how good the manipulation is based on how good the end effector of a robot
Hmm.
interacts with the world. Like, so if you want to pick something, if you want to pick a paper, how do you hold it? How much pressure do you apply, or
Okay.
what kind of friction do you expect, etc.
Okay. Okay. And what do you think is the future of like general purpose robots and the impact of the recent advancements in LLMs in accelerating the advent of robotics for broader scenarios and broader use cases?
I mean, I'm a optimist, and
Okay.
also I'm a roboticist. So I
Uh,
feel like the future is full of robots.
hmm.
I think the time is not too far before we get large scale adoption of robots into our lives.
What would that look like
Um,
if you could just like draw like a simple picture for people to understand? What would that look like?
yeah.
How
So
far away do you think that is?
yeah, ultimately what we want is like a robot that'll do all the work in the home for us, where we don't have to move. I mean, practically like we don't have to move unnecessarily for simple things. A
Hmm.
robot cooking for us, a robot cleaning for us, a robot like doing laundry for us, doing dishes, and taking care of every manual labor that we don't that we feel is like grunt work that we are doing every day. So
Hmm.
eating is a pleasurable task, but
Hmm.
washing dishes is
It's not.
not a pleasurable task for like,
I
I
can
mean, maybe
attest.
there is a
Yeah.
proportion of population that likes that,
Yeah.
but that's a minority.
Hmm.
So
Hmm.
all these kind of grunt work will be getting automated with robots is the
Hmm.
future. And even
Hmm.
further from that is like a robot that will also be emotionally interactive with us. So which
Hmm.
does all of these things and sits
Hmm.
in the couch in the living room and
Hmm.
has a chat with us, or
Hmm.
basically it'll be like a person without life. That's the
Yeah.
ultimate
Yeah.
future. Obviously, all the science
Hmm.
fiction that we have seen,
Yeah.
and
Hmm.
that's far away for sure. So both of these scenarios that I mentioned, a robot cooking,
Hmm.
cleaning, and doing all the household
Hmm.
chores,
Hmm.
is far away. Far away
Hmm.
in the sense like at least, in my opinion, at least like a decade and a half and 2 decades away.
Hmm. Hmm.
Um,
Hmm.
but like during this transition, we will slowly start seeing more and more adoption of these robots in our lives. Like
Hmm.
so,
Hmm.
a truly general purpose robots won't be here anytime soon, but general purpose robots which can work for specific application or which can be
Hmm.
fine-tuned for specific applications, I strongly believe will be around like in the next 3 to 5 years, starting
Hmm.
with a robot that does like in a restaurant, for example, a
Hmm.
robot that works as a server, like so who comes, takes the order, actually serves the food, cleans the table, sets the table for the next customer to come, or like someone who cleans the dishes in the kitchen in a restaurant. Those kind of things will happen in the next 4 to 5 years.
Hmm. Hmm.
So going from where we are, where the robots are only in industrial environments, to having
Hmm.
robots in semi-industrial environments like restaurants, laundries,
Hmm.
and things like that,
Hmm.
to having robots in our home, which will be like there can be
Hmm.
one robot in
Hmm.
in kitchen which does XYZ task. That's all.
Hmm. Hmm.
To the point where one single robot that does all the household chores, and
Hmm.
from there going to having another person in our home. So yeah, this
So
is the
so
trajectory I see.
essentially like a butler.
Yeah.
Okay. Okay.
Um, and I mean, in the ultimate state, is the penultimate state. Yes, it's like a butler, but like in the ultimate state, it can be
Hmm.
like a friend or a sibling or a family member.
Really?
Um,
Okay.
yeah,
Okay.
because like if it can emotionally interact with you and it's a
Hmm.
butler, then obviously it's a Batman scenario, right? Like so we have
Yeah.
someone who
Yeah.
is
Yeah. Yeah.
almost like a family member.
Hmm. What's interesting is that throughout, your life, I think you've ventured into the unknown. Whether it was with Explorer, whether it is with Dexter right now, you're constantly um, venturing into the unknown. You are someone who likes to take risks, and I want to go deeper into how you look at risk. You ventured into the unknown when you were building software for driverless cars. That requires an insane amount of grit and an insane amount of conviction. Do you think those two qualities are developed or inherent?
Um, I think it's it can be inherent for some people and it can be learned, and it also
Mhm.
depends on a lot of life experience that
Hmm.
makes it happen, right? Like for example,
Correct.
for
Mhm.
me, the first venturing into the unknown, truly unknown,
Hmm.
I would consider is going to work in Japan right after my master's.
Hmm. Hmm.
So when I came to US, obviously coming to US happened kind of accidentally for me, but like my sister is here, so it's not like so much of a venturing into unknown, because like I flew into my
Hmm.
sister's home and then I got a sense of how US is, and then I started living here or studying
Hmm.
here.
Hmm. Hmm.
But after master, I mean, at that point, like the idea is like I'm going to get a job in the US, repay my student loan, and then continue to settle in the US or maybe go back to India at some point, etc.
Hmm.
But what happened right after my master's is like I was very interested in working on robots. And
Hmm.
2011, 2012, just to give you an idea, that time robotics is not as like as sexy as it is now, or as popular as it is now, to
Hmm.
be honest. So most of the robotics work is in research labs and government-funded defense projects. And autonomous
Hmm.
vehicle work is also in the research area. Only Google was working on autonomous cars at the time. So
Hmm.
going to Japan at that time and working on robotics was the first aspect like that I would think is a venturing into unknown. And that's when I got to get taste of how fun it is and how exciting that is.
Hmm.
And specifically, like even coming back from Dubai to the US and starting Explore AI was the same thing. And it also depends on the stage of life for that matter. At the
Hmm.
time I was young, single, so obviously the threshold for risk was quite high. But now
Hmm.
I'm again
Yeah.
venturing into starting another startup, even having
Hmm.
a toddler at home and married
Hmm.
and like almost settled. Like so,
Hmm.
once you start tasting it, you can never go back. Is
Yeah,
what I would
that's
say.
powerful. That's powerful. That's powerful. But also, your beginning in the United States was kind of was in academia. So you started at Carnegie Mellon. Tell us about that transition from academia to entrepreneurship. I want to understand like what made you go through that change, and how did your academic background tangibly prepare you for entrepreneurship?
Yeah, as I look back right now, most of the work that I did in academia is application research and
Hmm.
also like
Hmm.
learning about how to take things from research labs into the real world. And specifically, given that I'm coming from a robotics background, most of any person who worked on robotics is basically a hacker at heart. So basically, people that tries to integrate and looks at multiple things and combine those and make something out of it
Hmm.
are the people that build robots.
Hmm.
So um, specifically, that kind of perspective helped me whether I was working on software products or whether I was working on robotics products or computer vision products.
Hmm.
And whatever I learned in academia, more than the knowledge, the wisdom of how to get stuff done was directly translatable to entrepreneurship. And it's not very different, to be honest. Like in both cases, you're venturing into the unknown and you're building things that were not built by anyone before.
Hmm.
It's just like the problem statement is different. There, the probably your goal is to publish a paper and like come up with like some research which moves the world forward. Here,
Hmm.
it's more like understanding what people need and building something and probably like making people pay for that.
Hmm. Interesting.
So
Interesting. Yeah.
it's a wisdom that was gained in academia that directly translated to that entrepreneurship.
I want to bring us to something that was at the heart of why I decided to build Saba, which is about investing in true innovation and building deep tech businesses, right? What is your understanding of the distinction between building tech versus building a product? So, like, this is especially relevant for deep tech startups where the focus is on building technology rather than defining a specific product that just sells, right? What kind of justification do you think is required to build startups that don't have a clear path to go to market but are deep tech in nature?
That's a wonderful question. And
Hmm.
specifically for deep tech, it's very, very relevant to understand to what extent like a product is like a mandatory aspect for building a startup versus you have like a cool tech and you're working on it. And
Hmm.
for what it's worth, it's a very hard question to answer as well.
Hmm.
So
Hmm.
here it's like a high stakes bet, right? Like, so you're building something for the future
Hmm.
where you have a strong conviction that like it's going
Hmm.
to move the world forward. At the same time, at the end of the day, you're not doing philanthropy, right? You're building a business. So the
Exactly.
revenue
Exactly. Yeah.
that you
Hmm.
make define whether you're a success or failure.
Correct.
It's
Hmm.
the same point that we touched on autonomous vehicles.
Hmm.
Um, like none of the companies between building autonomous vehicles is
Hmm.
super profitable yet. Not even super profitable is even profitable in my opinion yet.
At all. At all.
And yeah, exactly.
Hmm. 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 Hmm.
Uh, but at the same time, like the kind of satisfaction you get working on futuristic stuff is insane.
Hmm.
So specifically coming down to your question on thinking about go to market versus building tech or like building tech versus building product,
Product. Hmm.
um, it's a decision like one has to take for themselves individually.
Hmm.
So if you draw satisfaction from building a business and making a business work, then probably deep tech is like a very risky way
Hmm.
to go about it because you're not just optimizing everything on the cash component or the
Yeah.
revenue component, but you're
Yeah.
optimizing things on pushing things forward.
Yeah.
On the other hand, if you are driven by working on the coolest stuff out there, if you are
Hmm.
driven by building things that were never built before, and
Hmm.
if you're driven by imagining the future and solving a problem once and for all,
Hmm.
versus building a web app that solves a problem for today but like makes revenue,
Hmm.
I think deep tech is great. Like so, one aspect I specifically want to mention here is working on deep tech or building a startup or being an entrepreneur in deep tech will always have its returns for you. So
Hmm.
the best case scenario is like, yes, like like you'll have like a wonderful exit for your
Yeah.
startup.
Yeah.
Um,
Hmm.
the worst case scenario is you're still like super, what do you say? Um, like you're still going to be the most sought out kind of individual in the worst
Mm.
case scenario,
Yeah,
because you're working on something that doesn't exist now, and you're working on something very valuable,
correct.
and whose value will be defined by the future.
Correct.
So at the end
Hmm.
of the day, you're
Hmm.
learning about startups, you're learning about like the technology, you're learning about something new.
Yeah.
So it'll never go waste,
Yeah.
starting a startup in deep tech. And that's what I believe in, and that's why I'm doing this again.
Yeah.
Because the worst case
Yeah.
scenario for me is like I become more of an expert in a
Mhm.
well thought out area. The best
Yes.
case scenario is like I'll have like a wonderful exit,
Mm.
and like actually build a great business out of it. So
That
it's
makes
win-win.
sense. One of the issues that often come up when we talk about building deep tech businesses is that a lot of times, because of the larger investment horizon, so deep tech businesses typically burn cash for a longer period of time. So that J curve is a lot longer in the initial period. Um, so, what is your take on raising funds successfully to build breakthrough deep tech businesses? I know you've done it before. I'm sure you can share something with us so that some founders who are still struggling with that storytelling aspect, in order to get their deep tech businesses funded, they will find that immensely valuable.
Yeah. So few things changed over the last couple of years, to be honest. So even
Interesting.
for
Okay.
deep tech, the um, unless you're in this um, situation like where you can get like hundreds of millions of dollars, like with deep pockets, like so you're actually working on like very long term, very huge
Mhm.
bet. Uh, it's very hard to raise investments for deep tech without having like a go to market. So
Really? Okay.
one area that I strongly suggest, and like one area that I've learned in my experience, is to be in the peripheral businesses or like supporting kind of businesses for deep tech, like exactly like how we worked on mapping for driverless cars.
Okay.
Because
Okay.
in
Okay.
order to build a driverless cars, you need deep pockets. So if you can raise that, wonderful.
Hmm.
If that is not within the scope, one aspect is to build these peripheral businesses which support these deep tech companies, and like you can build it. So there's a lot of interest, and there are a lot of VC firms who just fund the supporting businesses for
Okay.
deep tech, supporting
Okay.
businesses for autonomous cars,
Can
or
you give me can
supporting
you give me
businesses
some,
for
can you give
robotics.
us some more examples for these peripheral deep tech businesses that you referred to? What are some more examples of that? What are some industries which walk us through some of the industries and maybe walk us through some of the VCs that you mentioned fund these particular peripheral startups.
Yeah, so definitely. So for autonomous vehicles, let's say the supporting businesses were, like I mentioned, the hardware companies that were working on just the LiDARs,
Hmm.
companies that
Hmm.
were working on cameras for these cars,
Hmm.
or companies that were working on mapping, like ours, or
Hmm. Hmm.
companies that worked on just like pedestrian modeling. So just taking a small component of it, which is not going to be the core aspect of like this bigger company. So if one of the mistakes or like one of the problems that will arise if the technology you're betting on doesn't succeed, like what happened to us, is that they wouldn't know which part of the stack is the core IP for them. So
Ah.
technically
Okay.
speaking,
Hmm.
mapping need not be a core component of an autonomous vehicle company. But given that like the business model for the entire autonomous vehicle space is not clear, no one wants to take a chance outsourcing that component.
Hmm.
So like
Hmm.
for example, even like LiDARs need not be like a core component of an autonomous vehicle company. Obviously, you should be able to go to a store and buy some LiDAR and put it on your car.
Hmm.
But the reason why almost all of the autonomous vehicle companies that exist now has like acquisition for one of the LiDAR companies
Hmm.
is that like they didn't figure out like what the money making piece in the stack is.
Hmm.
So
Hmm.
that's the risk, obviously.
Hmm.
But
Hmm.
on the positive side, like if you're building let's say a visualization tool for autonomous vehicles, Or if you're building like there is a company called Applied Innovation, which builds tools for autonomous vehicles and which was pretty successful. Or Scale AI was successful just focusing on data collection and data labeling for autonomous vehicles. So those are what I'm calling peripheral or supporting businesses for Deeptech.
Okay, but for specifically, like what are some peripheral businesses in other industries? And if you could give some examples of other industries.
Like you want to take ChatGPT, for example.
Sure. Okay.
Yeah. So for ChatGPT, the kind of peripheral businesses that exist are there are some companies which have experts hired, like experts in the sense like lawyers, doctors, and all hired, who actually label the responses from ChatGPT for reinforcement learning, basically, or like for improving the models. Because when you ask a question about medicine related or like a health related question, ChatGPT gives like a generic answer from internet, but unless real doctors are looking at it and validating whether something is right or wrong, the model will never know like what is the right way to answer a health related question. So there are companies which popped up who maintain these experts in-house and they keep labeling this. So that's one example. Or you have infrastructure companies which are definitely supporting businesses, companies that manage and maintain the servers or like some aspect of like this machine learning training. Let's say like if you want to visualize how your training is going, there are some tools like which you can use to improve that.
So to quickly come back to raising funds for a deep tech startup. I remember we were talking once and you mentioned that like, raising in Silicon Valley for a deep tech business or even any innovative business with any innovative business model is actually easier than raising in the rest of the US, which was such an important insight. We talked about how investors in Silicon Valley are not necessarily easier to pitch. It's just that they know a lot of the things already that are happening. They don't need to be convinced about the problem because they already follow it day in and day out, right? Could you give me a deeper dive into that? Kind of tell us about what kind of an experience is a founder expecting pitching to a Silicon Valley VC versus a VC in the US, not in Silicon Valley, so outside of Silicon Valley.
Yeah. The main aspect being them being up to date on like what exists and like what doesn't exist and what are the problems to bet on. Like we discussed the other day, if I'm pitching a particular product in, let's say, robotics, in Silicon Valley, it's easier to find investor who already knows exactly what problem problem exists in robotics and like they are looking out for solutions or they're looking out for businesses that build that solution. So it's easy to start this conversation and get them up to speed and focus on real aspects of how we are different from the existing solutions and things like that.
Okay.
Compared to other areas like where you have to start convincing people on that the problem exists in the first place. So for example, if I go to a VC like who doesn't know like the current advances in robotics, then I need to convince them that robotics is the future. And then I need to convince them that what are the parts of the robotics stack and like what are the parts that are unsolved, what are the parts that are problematic, and then start pitching my solution, which is like a really long journey, and like you actually don't have so much attention span from everyone. Just like to be very clear, I'm not saying it's a Silicon Valley versus non-Silicon Valley investors kind of persona. I'm talking about the density of or concentration of these investors that you find here. So if you meet 10 randomly chosen investors in Silicon Valley, 8 of them will be up to date on what's happening.
But not all of them.
Compared to other areas like where you will definitely have like those star investors. Obviously, like even in India or like Africa, wherever you go, you will find these investors like who are super knowledgeable and up to date. But it's just like the numbers are
lower.
Yeah, much lower.
Lower. Okay. Given all these structural challenges, like, can you tell us a little bit about like how you went about getting funded for Explorer AI and for Dexter?
Yeah. For Explore AI, we had wonderful angels and pre-seed investors that we took money from.
Hmm.
We had a combination of, I mean, majority of them are from the Bay Area, and like we had a combination of Bay Area and New York-based investors at that point.
Okay.
And
Who were they exactly?
we, so one of our first angel investors was Nick Heyman, who was, I think, like 18th or 20th employee at Facebook.
Okay. Okay. Hmm.
And then we have investor from New York, Ray Chung. And then we
Hmm.
have Story Ventures, which is also
Hmm.
a New York-based fund like that
Okay.
that
Okay.
invested in them. So,
Hmm.
and we have like Palm Drive Capital, which is in the West Coast, but like not in the Bay Area. So,
Okay. Okay.
whatever I said earlier, we still had a lot of investors from outside of Silicon
Huh.
Valley
Outside
investments,
that core group.
outside that core group. But again, as I
Yeah. Yeah.
said, the conversations w- with the, I mean, we had to like talk with a lot of people to filter out these like knowledgeable VCs that actually helped us
Hmm.
and got interested in.
Hmm.
Um, so the thing about deep tech is like it's hard to go to pitching events and get stuff done. It's more,
Yeah.
it should
Yeah.
be more
Hmm.
one-to-one kind of discussion or like connections, mutual contacts and connections before you
Hmm.
actually go and raise
Hmm.
money.
Yeah.
And that's one challenge there.
Yeah. Yeah.
And for Dexter, like I haven't still started fundraising. Like I'm building a
Okay.
prototype and I'm planning to
Okay.
start my pre-seed round
Mhm.
in a couple of months from now.
So, Sri, you told us about your experience with, going to multiple investors. You met a bunch of investors from New York, from various other parts of the Bay Area, not necessarily from Silicon Valley. Um, can you tell us how a founder today who's building in deep tech, how should he be thinking about his go-to investor strategy, so to speak? How should he think about how to approach the right investors?
Um, Two things to take into consideration.
Mhm.
One aspect is like over the last couple of years, things have changed significantly. So even whether you're building deep tech or not, like having customer traction is the core component. So having like a real
Hmm.
customer traction and go-to-market plan and like revenue generation plan is being sought out by every investor, even if
Hmm.
it is deep tech.
Hmm.
In terms of approaching investors, definitely like cold messaging is not a bad idea for sure if there is no circle for someone. But at the
Hmm.
same time, approaching people on LinkedIn and finding the mutual connections and getting connected to those is
Hmm.
a great direction to go about it. Because at the end of the day, VCs are interested in looking at like newer opportunities to invest.
Hmm.
So their job
Hmm.
is to find companies to invest in. So they'll be happy to speak with you, and getting a call is quite um, easy.
Hmm.
Converting this call is what makes it
Hmm.
hard.
Hmm.
At the same time, there are a lot of fellowships like On Deck Fellowship or a lot of founder communities like South Park Commons and
Hmm. Hmm.
Y Combinator, obviously.
You're a
And
part of you're a part of South Park Commons, right?
yes,
Hmm. Hmm.
yeah. So
Can you tell us a little bit
these
about can you tell us a little bit about South Park Commons?
so South Park Commons is basically a kind of an accelerator or an incubator, which has like two aspects to it. Like so, one is like the community aspect, and the other is like a founder fellowship. So community aspect is it just brings people working or like it just brings people from different spheres of technology
Hmm.
together so that there can be some interaction with people from different areas, like which can spur like interesting ideas and like great
Hmm.
businesses to be born. So that's
Hmm.
the community aspect of it. And the founder fellowship is like exactly like Y Combinator, where they put in some
Hmm.
money and they have like a specific 3 month or so kind of
Hmm.
curriculum that they want the startups to go through
Mm,
and graduate from it,
mm,
so that like
mm,
they start raising the money and like they make all the connections, etc.
mm.
So it's basically like a common. I mean, it's a interesting idea for South Park Commons, in the sense that like it goes. I mean, they define themselves as like -1 to 0 kind
Yes,
of
I've seen that. I've seen that. Yeah.
community,
Yeah. Hmm.
compared to everyone else, like which expect you to already have like a customer,
Yeah.
already have a product, already have a positive revenue, etc. So that's what
Mm.
keeps South Park Commons. That's what makes it different from
Sets it
everyone
apart.
else.
Yeah.
Yeah.
Yeah. Mm,
Yeah, so there are these communities, which, I mean, for example, on deck fellowship is quite reasonable. You can
mm,
attend there. I think they very frequently have this kind of workshops and like sessions.
mhm.
And these communities definitely will play a huge role. So once you get into one of these
Okay.
communities, you will know where to look for and how to look for the investors and all. Like, so I'm talking about someone
Mm,
with a cold start. So if someone
mm,
already has a network, obviously mutual connections makes the best introduction. So
mm,
that's the way to go.
You talked about the centrality of having traction when you approach investors, but especially when it comes to deep tech businesses, which often need funding at lab stage, right? At lab stage, you're still building the product, right? You don't really have traction then. Like, how do you kind of it's kind of a chicken and egg problem, right? Like, how do you deal with that issue if you don't have traction yet because you're still working on the product?
Yes. So it varies case to case. Depends on what exactly you're
Mm,
developing.
mm,
And while, I mean, there is a reason why there is expectation of traction and there is expectation of some sort of product development before approaching a VCs now, is because getting that initial product or proof of concept out and getting that initial conversation started with customers is
mm,
also has also become easier,
mm,
with like the latest advances, right? Like,
mm,
so it is possible to build an application or build a solution, whether it is in deep tech or not, with minimal cost right now, with
mm.
minimal number of people,
Yes.
and like take it out there. So
Mm,
that's the expectation that's also coming from the other side.
mm,
So, but like that's a hard question to answer. Like, so definitely it's a chicken and egg problem.
mm, mm,
Either you build things in simulation. For example, in robotics, one of the things that you can do is like you can do everything
mm,
in simulation and
mm.
then take it to the customers, take it to the VCs, and say that once funded, you can actually translate that to the real world. That's one option.
Sure.
Or
Mm, mm,
you
mm,
can actually bootstrap, like if you can like put some of your money and like build the basic stuff and then
mm,
take it to the customer and like get some customer
mm,
feedback. So the traction need not be already like paying customers,
mm,
or the traction can be just that the customers are really interested and they're piloting your project, or like they're
mm,
becoming design
mm,
partners for you to develop.
mm, mm.
So that at least will get it started. So
Sure.
involving customers and like getting the customer interest
Mm.
is the point that is super mandatory compared to anything
Okay.
else.
What are some challenges and bottlenecks to building deep tech businesses? We already talked about the funding problem, right? Like, but apart from funding, what else do founders face on a day-to-day basis that makes building deep tech businesses harder? What do they lack access to? That's what I want to understand from you.
Yeah. So one problem there is a lot of things are going to be uncertain. If you're building
Mm,
deep tech business, as a B2B business, it's even more challenging because the customers that are working on other deep tech, or like a bigger deep tech solution, might not be very clear about like what exactly their product is going to be. So they
mm,
might just be out of research. So
mm,
the requirements keep changing very often, and being agile for that like is really important. And that's why
mm,
I emphasized on the point of building blocks earlier. So
mm,
if you have like nicely built building blocks, then it'll be easy to have have the agility to switch between different use cases on different
Hmm.
products.
Hmm.
And the second aspect is approachability to the customers, which is really hard because customers in this kind of environment, like, so if you're working on B2B aspects,
Hmm.
definitely, like, it's very hard to reach out to them because they are also working on taking research stuff to production,
Hmm.
and their
Hmm.
requirements keep changing very rapidly, and like being able to
Hmm.
mold to that changing kind of requirements is required for a founder working on
Hmm.
deep tech startup. Like
Hmm.
the main aspect to consider is to build like really solid building blocks, which will help you change the product you're offering to different customers based on their changing needs. And the
Hmm.
second aspect that is very crucial here is the ability to convince these customers that like it's a need. If you're directly building B2C kind of solutions where your customers are individuals or people directly accessing your product,
Hmm.
then the expectations are hard to manage. Like there
Hmm.
is a lot of noise that will be created by these large companies,
Hmm.
which is very hard to justify. For example, NVIDIA claims that simulation is a solved problem in the recent GTC.
Yes.
Because
Hmm.
like
Hmm.
they could actually come up with like real world physics engines and all, but it's not as black and white as they say it,
Hmm.
right? Like
Hmm.
our ChatGPT can say video generation is a solved problem
Hmm.
because they have Sora.
Hmm.
But in media and in news, like you see a lot of noise that all of these are solved problems. And now if you go to a customer saying that I have a basic video generator,
Hmm.
the expectations of the customers are like very different from what your product offering will be. So
Hmm.
navigating this
Hmm.
clutter and decluttering this kind of noise created by the media and like these large corporations is a big challenge for founders of startups in deep tech right now.
So my last question for you is, so there are a bunch of founders and investors who are looking to build in the spaces that you have already built in or are building in right now. So autonomous vehicles, AI mapping, robotics. What would you suggest to those people in terms of resources and actionable steps they should be taking in order to successfully build?
Definitely um, try to minimize the costs on the prototyping.
Okay.
As
Okay.
I mentioned,
Mhm.
building a prototype should be much cheaper right now compared to sometime in the past.
Hmm.
So if you're specifically working on modeling aspects or GPU hungry kind of processes, then
Hmm.
it's a slightly different story. But like as long as you're not working on foundation models on for any of these,
Hmm.
you should try to minimize the cost for initial prototyping. And that's actually possible with all the tooling and with all the
Hmm.
resources that are available out there. Like,
Hmm.
for example, you can start building with whatever exists on Hugging Face to bootstrap your product. And
Hmm.
once you raise the money, you can actually build your proprietary models and other stuff. So even before that, like if you're at a discovery stage,
Hmm.
definitely trying to utilize the available resources and available models online to build your solutions on top of it, like specifically for AI and robotics, and
Hmm.
using simulation and synthetic tools for robotics to be specific, will
Hmm.
keep the cost down. And that's
Hmm.
going to give you a lot of freedom to explore in different directions.
Interesting. Interesting. Sri, it's been great having you on the show. I think there were so many rich insights that you provided. Um, Thank you so much for taking the time to do this. I look forward to having you on the show again. Thank you.
Thanks, Em. It was wonderful having this conversation, and I really liked the questions you asked.